For our first example, let's create a resource that retrieves a value from an environment variable. In particular, this API URL environment variable. We'll create a resource based on the variable, and then we'll inject that new resource into our display service so that we can use it in place of this hard-coded value of our API URL. So remembering the 4 steps to implementing dependency injection for a non-class resource. The first step is to create an injection token. And I'll create the injection token right here in display service. Typically, you would create your tokens and provider objects in separate files in your application. But for the sake of these examples, I'm just going to create the injection token right here in the display service. And I'll export it so that we can access it publicly, and we'll call it API URL token. And we'll use the injection token class. And I'm going to type our API URL token, and it's of course a string. We saw that in the environment variable file. And we'll give it, and we'll pass the constructor API URL. Now, typically what I do is I give my injection tokens descriptive names and in them with the word token, and then I'll pass to the constructor, the injection token constructor method, I'll just pass that same variable name minus the word token. So that's just my own personal convention, but you can use anything that you like. So we've created our injection token. So this is step 1. Step 2 is to create our provider. Now I'm going to create a root level provider, and I'm going to place it in the application config. My Angular application is a standalone application. So I have an application config file, and notice the providers array has already been set up. Now I'm going to combine steps 2 and 3 here in the application config object. I'm going to both create the provider object and register it at the same time, because registering it is simply adding it to this providers array. So let's create the provider object. And if you remember, the provide property is the injection token name that you're creating the resource for. So that we just created, it's API URL token, and we're going to use useValue because the environment variable is simply a string. It's simply a value. So we can use the useValue property to simply retrieve that string, and we'll set useValue to environment. I'm going to use this one, and it's the API URL. So with that, we've just created our provider object and registered our provider object here in the providers array, the providers property of the application config object. So now our only remaining step, step 4, is to inject our new resource into the display service. And display service already has the HTTP client injected into it. And now we can also inject into it our API URL token. And if you remember from our discussion, when we inject the resource, this non-service, non-class resource, we have to decorate its variable name with the inject decorator. And we're going to pass into the inject decorator our token, and we'll give our variable the name API URL, and it's a string value. So now we have our resource injected into our display service. However, it's not yet being used. We're still using the hard-coded value from info URL. So, and to prove that, let's comment out info URL. And of course, we get a compilation error. And let's replace that with our API URL resource. And there you have it. Everything is working as expected. We've created a new resource from our environment variable, and we've injected that resource into our display service, which is using that resource, that newly injected resource. And once again, our display service is working. It's connecting to our backend using that environment variable. And with that, we have our first example of implementing dependency injection with a non-class resource, specifically a value resource. Two things I want to mention before we move on to the next example is, one, I want to prove that the environment variable is being used to connect to our backend. And I'm going to do that by going into the environment variable and changing this. And we should get an error. And we do indeed. We see that in the console. We're getting that error because it's not able to connect to the backend. So that error is coming from our HTTP GET call. So that proves that we are indeed using the resource that we created to retrieve the API URL from the environment variable. Display service is indeed using that resource. So that's one thing I wanted to mention. The other thing that I wanted to mention is, you might be wondering, why would I go through all of the trouble of creating a provider for this environment variable when I could simply have replaced here, I could have replaced the hard-coded API with the environment variable itself. Directly using the environment variable in our display service code is tightly coupling our display service with the environment variable. It's the same as when we created an instance of the simple service in our components. And that's what we want to avoid. We want to avoid tightly coupling our resources with our consumers. This implementation is doing just that. So to avoid tightly coupling our service with our resource, we create a provider object. And what that allows us to do is, if we no longer want to use the environment variable as a source for our API URL, if we wanted to use some other file or configuration object, we'd simply change it here in our provider. We wouldn't have to change our display service code. And I can do that right now by using an actual value instead of the environment variable. I can use the actual value, and once again, everything works perfectly. We're still connecting to our back end. So while it may seem, very involved creating provider objects for our resources, it's enabling us to future-proof our code and to avoid tightly coupling our consumers with our resources. Now let's take a look at the useClass and useExisting properties of a provider object. For this example, let's replace the use of display service in our components. Let's replace that with the use of simple service. And for this example, let's switch out the descriptive text so that it no longer says without dependency injection, coming from simple service. Let's now replace display service with simple service in our components. And we can do that by creating and registering a provider. Let's create a new provider that states when a consumer wants a display service, let's have it use the simple service instead. And for that, we use the useClass property. And we set useClass to simple service. And it's as simple as that, no pun intended. But now our components have replaced the use of display service with simple service by registering this new provider that instructs Angular to do just that. This provider object instructs Angular to replace all requests for display service with simple service. And that's what we're seeing in the descriptive text. So that's a very good use for useClass to replace one class with another. Now, the thing about useClass, though, is that it always expects a class. It always expects a service. So we couldn't set useClass with, let's say, a new instance of simple service in this manner. Notice this doesn't work. And our error is telling us as much. It's telling us that the property of useClass is incompatible with what we just passed in. We didn't pass it the actual class. We passed it an instance of the class. So the only acceptable value for useClass is a service, is a class. Now let's change the useClass property with useExisting. And notice we get an error. We get that no provider for simple service error. And the reason that we're getting that is because indeed, simple service has not yet been registered. There's no provided in property in the injectable decorator for simple service, and it's not one of the providers in our application config object. So that's the requirement of useExisting. useExisting requires that the resource be registered. Now, if we register our simple service by adding the provided in property to its injectable decorator, that registers simple service, and notice the error goes away and useExisting is now working. And that's only because simple service is registered. That's the requirement of useExisting. However, don't think that useExisting can only take a service or a class the way that useClass did. That's not the case at all, because if we create a provider, a new provider for simple service that is from, let's say, a useFactory, and we'll have useFactory return an instance of simple service. Well, now this all works. It's using the existing simple service, which here in our providers is no longer the simple service itself. It's actually an instance of the simple service class. And if we go back and we remove this registration from simple service, everything still works. We're not using the simple service class itself in our useExisting. We are using this new resource that we've created with this provider object. So those are the two things to remember about useClass and useExisting. With useClass, you have to use an actual class or service. The class or service does not have to be registered, but it indeed only accepts a class or service. useExisting requires that the resource has already been registered. It doesn't have to be a class. It can be a factory. It can be created using useFactory or useValue or anything else. It doesn't have to be a class, but it has to be a registered resource. So those are the two differences between useClass and useExisting. And there's one other thing that I want to show you about classes as well. So I'll comment out both of these provider objects, and with the simple service, it's not registered using provided in. But let's go back to the application config, and if I add simple service to this array of providers, like so, simple service becomes registered. And now if I uncomment the useExisting provider object that replaces display service with simple service, notice everything works. Once again, display service is being replaced with simple service via useExisting. And I can use useExisting because simple service has been registered, and it's been registered by adding simple service itself to the provider's array. So this is yet another method for registering a service. We can register a service, remember, by adding the provided in to its injectable decorator, or we can add the service directly to our array of providers. And one other thing to note is that there are a couple of different variations in the way that we can add a service to the provider's array. This is one, and I'll comment this one out. And we can also create a provider object for simple service in this manner. And notice there is no useClass or useExisting in this provider object. And that's because the default for a provider object is actually useClass. And the setting for useClass will be the injection token that you use in the provided property. So that's one way. And we can also add the useClass property as well. So this just goes to show there are a few different ways of registering a service. We can register it via the provided in property being added to the injectable decorator. We can register a service by adding the service itself directly to the provider's array, or creating a provider object using the service. But again, remember that the provided in method is the recommended method. And that's because while creating a provider object using the service class itself in this manner, or by adding the service to the provider's array, while these work in exactly the same way as the provided in method, these forms of registering the service are not tree shakeable, and the provided in method is tree shakeable. That is, the code will be removed in our build if simple service is not used. So while all of these registration methods work in the same manner, the provided in method is the recommended way to go about it. So now that we've seen how to use useClass and useExisting and useValue, let's take a look at our last type, and that's useFactory. Now, just a short while ago, I gave you a glimpse into how the useFactory property works when I created a provider object using useFactory that returned an instance of simple service. But I really want to show you how to use useFactory with the dependency or deps property also being set within the provider object. For this example, I want to modify the simple service so that it gets injected with a new resource. And I want that resource to be the descriptive text that we see in the source property. So to do that, of course, we first create an injection token. And I'll call this injection token source info token. And again, I'll use the injection token constructor method, and I'll type it with string. And I'll pass in just the source info portion of the name. So now we've got the injection token created and I'll inject the constructor method of simple service with a resource that's created using that source info token. And if you remember, we need the inject decorator. I'll use the import, and we'll pass into the inject decorator the token, the source info token, and we'll call this source info, and it's of type string. And now let's use it in our simple service by replacing this hard-coded descriptive text with the value coming from the resource, the injected resource. So that's all created. Now, the only thing that we have to do is back in our app config, we have to create a provider that instructs Angular how to create this injection token, this resource. And let's do that above the provider that is creating the simple service resource. And for this provider object, we'll use the source info token, and we can simply use a value for this, and we'll pass the value simple service using token. So now we have a provider for our source info token. Now let's create simple service using useFactory instead of useClass and pass it the dependency of the source token that we need. And we do that by setting the useFactory class. And of course, useFactory takes a factory function, and we'll have our factory function return a new instance of simple service. But now simple service expects a source info parameter to be passed in. So let's call this source, or src, and we pass that as a parameter in our factory function, and it needs to be a string. Now, to have this dependency fulfilled, because right now, as you can see, it's undefined, to have it fulfilled, we use the deps property, and that's an array, and we can pass into that array our source info token that we've just registered. And now, as you can see, we're getting the descriptive text from our source info token provider. So that's the way in which we use useFactory with the deps property. Now there's still one remaining property of the provider object that we have to discuss, and that's the multi-property. To demonstrate the multi-property, let's first comment out all of these providers for simple service and have our components go back to using the display service. And if you remember, display service has injected into it the API URL token. And currently there's only one API URL token provider object in our application config. And of course, for this provider object, multi is currently set to the default, which is false. But now let's set it to true, and let's create another provider object using that same token and also setting the multi property to true. But let's have this provider return an invalid API URL, something like API info with a few Z's. So we know that this is invalid. Now, when we do this, as I stated in the discussion, an array is created, an array of these providers. And because these providers return string values, it's returning an array of strings. And now, as you can see, our display service is broken. Our display service is now returning an error. And that's because display service, the API URL token that's being injected into it, is no longer returning just a string value. It's returning an array of strings. So now let's first use the valid API URL token, and that's the one coming from our environment variable. So that's element 0. Let's return element 0. And now everything works. We're no longer getting an error and we are connecting to our back end. But if we change this to element 1, we'll get an error. And of course, we get that error because element 0 in our provider objects array is an invalid API URL. Now, if we make this a valid API URL, everything will work. So that's the way in which we can use multi. Now, let's see what happens if we change both of the multi properties back to false. Well, we get an error. And the reason that we're getting an error is because back in our display service, we're saying that the resource is an array, when now that we've set the multi property to false, it's not an array, it's a single string value. And now everything works. And remember what I said, the last provider using that API URL will be the one used. So if I make the last provider object invalid, we get an error because the provider object, which is actually valid, the one coming from the environment variable, is actually overwritten by the last one in the list of provider objects using that token. So that's what occurs when the setting is false. Now you might be wondering, and let's return this back to a valid value. Now you might be wondering, well, what happens if I mix true and false multi-settings? And I'll do just that. And of course we get an error, and look at what our error tells us. Cannot mix multi-providers and regular providers. So even if you try to have different multi-settings for the same injection token, you do indeed get an error. So they all have to be set either to false or to true, but not a mixture of both. And with that, we now have covered all of the properties of provider objects.